Welcome to Spaceverse, your portal to cosmic adventures. Get ready for an exciting ride. In today's episode, NASA spills the beans on their Mars landing secrets. Voyager 1 phones home after a long silence. Japan gears up for another shot at a lunar landing. And China's moon rocks reveal mysteries from the far side. Let's start with Mars. How do we land on this enigmatic planet? So far, NASA's nailed it with some pretty wild ideas. Bouncing giant airbags and an epic sky crane maneuver. Cool, right? But here's the kicker. Neither of these techniques is practical for landing humans or heavy equipment on Mars. What's NASA's game plan? Turns out, they've been quietly learning how to handle much bigger payloads on Mars, and they've been taking notes from SpaceX, but not the way you'd expect. No, this isn't about Starship. This story dives deep into an intriguing interview with Robert Manning, NASA's chief engineer for the Sky Crane system, featured in Universe Today. Manning drops a jaw-dropping truth bomb. Back in 2007, NASA thought landing humans on Mars was flat-out impossible. But in 2013, everything changed. Here's the big challenge: Mars' thin atmosphere. It's a tricky middle ground between Earth and the Moon. You'd think that would make landing easier since we've done it on both, right? Nope. Landing on Mars is a whole other beast. Landing on Mars isn't as straightforward as it might seem. The planet's atmosphere creates a Goldilocks problem, too thin to use atmospheric drag like we do on Earth, but too thick to rely solely on propulsive braking as we do on the Moon. Why is that? It's all about the supersonic transition problem. Until about a decade ago, NASA believed you had to slow a spacecraft below the speed of sound before engaging retropropulsion, the rockets that act as brakes. On the Moon, with virtually no atmosphere, this isn't an issue since sound doesn't exist there. But Mars has just enough atmosphere for sound waves to be a factor. Now imagine this: a spacecraft hurtling into Mars' atmosphere at interstellar speeds, about 20,000 kilometers per hour for the latest Mars rovers, and even faster for a crewed mission. There's simply no way to slow down to subsonic speeds before slamming into the Martian surface. NASA tried all kinds of solutions: bigger parachutes, inflatable decelerators, but none proved reliable enough to slow the vehicle down to the point where traditional engine braking could safely kick in. Manning shares an intriguing moment from the interview. There was one trick we didn't know about. What if we used our propulsion system and fired the engines backward, retropropulsion, while moving at supersonic speeds to slow down? Back in 2007, we didn't know if that was even possible. What's fascinating here is that one of the top engineers at NASA's premier laboratory didn't think it was feasible to fire engines at supersonic speeds into the atmosphere. Why was that? Manning goes on to explain. When you fire engines backward while moving through an atmosphere, a shock front forms that moves around. It could slam into the vehicle, making it unstable or causing damage. Plus, you're flying directly into the rocket exhaust plume, which could lead to extra friction and heating. It's not that they weren't curious to try, but there was never a practical reason to attempt it. NASA didn't have the budget to launch a vehicle into space just to see what would happen. But Elon Musk did. For Falcon 9 to successfully land in the ocean, they must perform a re-entry burn to slow down during the supersonic phase. At the altitude where this burn occurs, there's still a thin layer of Earth's atmosphere, and the engine is fired directly into it. Manning and the jet propulsion team quickly realized that this re-entry burn closely mimicked the conditions that would be needed for a propulsive Mars landing. What NASA discovered from studying Falcon 9's supersonic retropropulsion was that they had been wrong about everything. In 2014, NASA and SpaceX launched a 3-year public-private partnership to study Falcon 9, known as the NASA Propulsive Descent Technology Project. The SpaceX boosters were equipped with special instruments to gather data on specific aspects of the entry burn, which aligned with the Mach numbers and dynamic pressures NASA expected to encounter on Mars. The project also included visual and infrared imagery, flight reconstructions, and fluid dynamics analysis, all contributing to NASA and SpaceX's growing understanding of how to land on Mars. The most significant revelation was that the shock front created by the engine firing, which NASA initially thought could destroy the vehicle, actually forms a protective bubble underneath the rocket. This bubble insulates the spacecraft from turbulence and heat. With this insight, NASA now believes that supersonic retropropulsion is the only viable method for landing heavy equipment, habitats, and even humans on Mars. Next up, NASA needs to figure out just how much aerodynamic control a vehicle might have while traveling at supersonic speeds in Mars' thin atmosphere. In other words, how do we steer the spacecraft before the final landing burn kicks in? Once again, we're learning in real time from SpaceX. When the Starship vehicle begins to re-enter Earth's atmosphere, it's traveling at speeds over 20,000 kilometers per hour, using its flaps to guide the vehicle. At altitudes between 70 and 100 kilometers, Starship is essentially practicing for its Mars landing. NASA is taking full advantage of this opportunity to learn. The next flight of Starship will return to nighttime re-entry and landing. A key reason for this is that NASA wants to track the descent using a thermal imaging camera mounted on a jet airplane. Just like with Falcon 9, this is the first time we've had a chance to experiment with something like this, so we're gaining a lot of valuable insights about landing on Mars without even leaving Earth. Moving far beyond Mars into deep space, NASA has reconnected with an old companion, Voyager 1. The probe is alive and well, with communication just restored after a blackout that began in October. At 47 years old, Voyager 1 is now 25 billion kilometers away from Earth. With its plutonium power supply running low, only 4 instruments remain operational, and they are functioning at much colder temperatures than originally designed for. When engineers instructed Voyager 1 to activate one of its heaters to warm up the instruments, a safety feature was triggered. Due to low power, the spacecraft's fault protection system automatically shuts off non-essential systems when energy levels drop too low. However, the issue was that all non-essential systems had already been powered down long ago. In response, the fault protection system turned off the main X-band transmitter and switched to the lower-powered S-band transmitter. But due to Voyager 1's immense distance, signals from the S-band antenna couldn't reach NASA's deep space network, effectively silencing the spacecraft. After a tense period, NASA was able to restore X-band communication in late November. The spacecraft is now once again transmitting data from its 4 remaining instruments: the Low-Energy Charged Particle Experiment, Cosmic Ray Telescope, Triaxial Fluxgate Magnetometer, and Plasma Waves Experiment. NASA remains hopeful that both Voyager probes will last long enough to celebrate their 50th anniversary. On a different front, Japan is preparing for another attempt at landing on the Moon in January 2025. Their Resilience lander, developed by the private company iSpace, has arrived at Cape Canaveral, Florida, for integration with a SpaceX Falcon 9 rocket. This marks iSpace's second lunar mission, following their first attempt to land on the Moon in April 2023, which ended in failure due to an altitude sensor being misled by the rim of a large crater. The sensor caused the spacecraft to mistakenly think it was closer to the lunar surface than it actually was. The new Resilience lander is based on the same Hakuto R platform as the previous one, but comes with an upgraded software system. It was transported via a commercial cargo plane from Japan to Florida. This mission will also carry a small rover named Tenacious, developed by iSpace, along with commercial and scientific payloads. The mission is expected to support NASA's Artemis program. On the topic of the Moon, China has begun analyzing samples from the recent Chang'e 6 mission to the lunar far side, and early results are providing new insights into the Moon's volcanic history. A study published in November reveals that volcanoes were actively erupting on the far side of the Moon as recently as 2.8 billion years ago. This is significant because, unlike the near side, which has dark volcanic plains that are well known to us, the far side has far less evidence of volcanism. Researchers are still working to understand why the far side of the Moon shows such a different volcanic history compared to the near side, and the newly collected rock samples from China are helping in this investigation. One notable discovery is that the hardened lava from the far side contains significantly lower amounts of potassium, rare earth elements, and phosphorus compared to the near side samples. This points to not only a difference in volcanic activity between the two hemispheres, but also a major contrast in the composition of the rock. The leading theory is that this could be related to the massive impact crater known as the South Pole Aitken Basin, which may have played a key role in shaping the geological characteristics of the far side. And that's it for today's Spaceverse. From Mars landing breakthroughs to Voyager 1's comeback and new lunar discoveries, the universe is full of surprises. Don't forget to like, subscribe, and stay tuned for more.